All right, we're back with key topic 15. That's medium frequency to high frequency equipment controls. So far, we've been looking at the very high frequency, VHF. So these are a little slower as far as the frequency is concerned. The wave lengths are longer. There's less in an inch than there is for very high frequency. So let's take a look at these. First of all, we're going to take a look at this regulation in Part 80. It's subsection 359, frequencies for digital selective calling, the DSC service. During working hours, all public coast stations capable of DSC operations must monitor the worldwide and regional frequencies appropriate for its location. So it's basically telling a public coast station they must listen in on the frequencies plural. So basically, it's charging them with monitoring all the frequencies. All the frequencies appropriate for its location. If something is only applies on the other side of the continent, then no. B, distress and safety calling. So the frequencies are listed here. 2187.5. These are, we did kind of look at that already. Kilohertz is 1,000, so we can see it's like 2,187 kilohertz. So we can kind of move the decimal over 3 parts and just call it 2 megahertz. 2,000 kilohertz is the same as 2 megahertz. It's a way to kind of quickly scroll through these medium and high frequencies. So this one is in effect 2 kilohertz, the next one's 4, the third one's 6, the fourth one's 8, the fifth one's 12, and the sixth one is 16. Now, 2 is still the one that's in the medium frequency because it changes from 3 to 30. So 4 is over 3, so that's at the beginning of the high frequency band. So is 6, 8, 12, 16. It wouldn't be until you get up to 30 that you would actually hit the very high frequency. And that goes from 30 to 300. And you can see the seventh one they're listing here is the 156 megahertz. So that's over 30 and under 300. So that's in the VHF band. Many times when they're referring to the medium and high frequencies, they'll look at these 6, and they won't necessarily include channel 16. Well, actually, 156.525 is what? That's channel 70, the DSC channel, digital selective calling. All right. So these are the safety and distress calling channels. They can be used by ship stations on a simplex basis for distress and safety purposes, and we're going to talk about simplex a little more today too. They may also be used for routine ship-to-ship communications, provided that the priority is accorded to distress and safety communications. Yeah, some of these are not going to be used all that often for distress. I mean, the 12 megahertz is probably not going to be used nearly as much as the channel 70 or the 2187, 2182. I'll look at that a little closer as we go here. So this is a nice little diagram that explains the frequencies. You can see they jump from 3 to 30, 30 to 300. So keep adding a 0 in effect. It gets a little difficult when they're changing the kilos to the megas and then into the gigas in the high end, which we've mostly been looking at 2182, which is a medium frequency distress signal. And that is in the higher part of the medium frequency band. And then that's one of the six. Then the other five, 4, 6, 8, 12, and 16, we looked at those already, just now. Then you get over 30, you're into the very high frequency, and you could see the first three are ones that we've already talked about. 121.5, that's more for aeronautical, and for the COSPAS, SARSAT, EPIRBs, SARTs, ELTs. These are all at 121.5 megahertz. There is a little parentheses that states that that was terminated, but most of the equipment still monitors it. 156.525, that's channel 70, the DSC. 156.8 international VHF distress frequency. We haven't looked at AIS yet. That's a little bit higher in the same frequency zone. That's like a automatic identification system that ships use, similar to the transponders in an aircraft, where air traffic control knows what ships are out there based on their uniquely assigned code. AIS is very similar. It's a little different in the seas than it is in the air. Not all ships basically follow that. I think some countries feel it's a little bit of an invasion of privacy, so you're not going to necessarily get the automatic identification system reading all traffic in the area. But it is basically done for collision avoidance, etc. 406 we're going to be starting to touch on. That's more of the modern and the satellite distress frequencies. So we haven't touched on that too much. We will be getting into it. And the SARTs and the Inmarsat. So basically these are the frequencies that we'll be looking at. And you can see them spread through the radio spectrum. I'll go ahead and entertain a question on this. Why must all medium frequency to high frequency distress, urgency, and safety communications take place solely on the 6 assigned frequencies and in the simplex operating mode? Did we say that it is in the simplex operating mode? We should have. Basically, part of the reason is going to be one of these answers below. So let me launch a poll. And let's see what our options are. Okay, I can see B is already going to try to confuse us. Both A and C are correct. They don't actually put it in the right spot, but let's go ahead and read these. Why must those type of communications take place on those channels in that particular mode? A, for non-GMDSS ships, probably a pleasure ship or maybe a passenger ship that's under a certain tonnage, or I mean a cargo ship or a passenger ship that's under a certain number of passengers. Those type of ships, why should they only use those channels for distress, urgency, and safety communications? Is it to maximize the chances for other vessels to receive those communications? If you're not tying up those channels, that doesn't sound bad. C, for the GMDSS or the digital selective calling equipped ships to maximize the chances for other vessels to receive those communications. Well, it's basically the same as A. So non-GMDSS to maximize the chances for other ships, for GMDSS to maximize the chances for other ships. So B doesn't look like a bad answer, because both of those are in effect saying the same thing. Or D, to enable an RCC or coast station to only hear communications from the vessel actually in distress. RCC is a rescue control center that is set up by the Coast Guard when they actually have a rescue going on. So they'll set up a center and they abbreviated RCC. Would that type of center or the coast station only want to hear from the vessel that's in distress? Or basically they would probably want to hear from everyone. So everyone that's got something to do with the rescue. So I don't like D. So what are we going for? A and C? Yeah, that sounds fine. It is. Or most, not 100%, but that's fine. Basically, those communications take place on those frequencies to ensure that both types of ships may simultaneously receive those calls. And all shore stations monitor all 6 frequencies. All right, here's a question about your power level. Medium frequency, high frequency transceiver power level should be set. Where do you adjust your power? And some people call it volume. Do you set it to the lowest level necessary for effective communications? Or do you set it to the level necessary to maximize your propagation radius, how far out you actually are transmitting? C, to the highest level possible so as to ensure other stations cannot break in on the channel during use? Or A and C? Oh, this section has some goofy options. All right. Basically, how are you going to, let's say this is your volume on the top. You're going to want to use the radio. Where would you set it? Would you set it all the way to maximum? Probably not. It'd blow your ears out and blow out the ears of other people. And that's a little bit more than you need. Maybe in an emergency you might be shouting, but generally you do not take it to the maximum. So in effect, B says the maximum, and C is kind of saying the maximum to the highest level possible. So you don't necessarily want to, if you're only going to talk to a nearby ship, you do not need to maximize your projection radius out to the other side of the state. So you can pretty much tone it down to A, the lowest level necessary for effective communication. Stop the share on that. We didn't do as well. Okay, the caption does say that the single sideband radios have a low, mid, and high power output selection. I'll have to take their word for that because it looks awful. Okay, there is a power button. The first button all the way on the left says power. Next to it does say volume, an up arrow, a down arrow, and a clarifier button. All right, I guess I can see those fairly well. All right. So power is different than volume, as you can see. In this case, I think it's just power on or off, and then you adjust your volume. Another button that we look at, well, another couple buttons, I guess. So sometimes they're on the same button, and you basically cycle between the two screens. But the RIT and the XIT. RIT is the receiver incremental tuning, is the ability to shift and shift the receive frequency of a transceiver away from the transmit frequency by a small amount. So basically you're in effect tuning it. You're tuning it just on and off a little bit, maybe you're getting a better reception with that little tweaking, fine tuning of the receiver. And then same for the transmitter. It's, as a matter of fact, it's the same words. For some reason, aviation likes to use X instead of trans. Transponder transceivers, you're going to see Xceivers, Xbonders. But in this case, incremental tuning is basically doing the same thing but with the transmit frequency. Particularly when you're using duplex and you're receiving and transmitting on different frequencies. Both were very useful in older rigs that had frequency stability problems and in current systems using some homebrew transceivers or separate transmitters and receivers. All right, so basically that's the fine-tuning button. And here's the question. What is the purpose of the receiver incremental tuning, the RIT, or also called the clarifier control? As a matter of fact, I think we saw that in the previous, when we were looking at the bottom one with the buttons. One did say clarifier. All right, I relaunched the poll. We'll see what how people answer. All right, so what is the RIT? A, it acts as a fine-tune control on the receive frequency. B, it acts as a fine-tune control on the transmit frequency. C, it acts as a fine-tune control on both the receive and transmitted frequencies, or none of the above. All right, RIT, that was receiver incremental tuning. The XIT was the transmitter incremental tuning. So receive frequency, yes, A. B, that's the transmitted frequency. No, that's the XIT. Both, no. They're specifically asking the RIT. The simple fact that you are saying that it is a fine-tuning control means you're halfway there. I'd be tempted to give half credit for any of the two answers, but if you can zero it down to the receiver, which is part of the question, what is the purpose of the receiver tuner? It's to fine-tune the receive frequency. So a careful reading of the question should get you to the right answer. If you have both, you're not affecting the transmit frequency. Why wouldn't you? Because the person that you're transmitting to, let them do the fine-tuning. It's pretty hard to fine-tune when you're not actually listening in on your own voice. There is a side tone, but I'll get to that at some point, maybe. Probably not. All right, end poll. All right, I guess they're going to start asking about these emissions. So I'm going to break it down a little bit. There's 3 characters. And the 3 characters, and the first example is going to be J3E. And we use that quite a bit. That's in effect the synonymous for our purposes with single sideband. But the 3 characters, the first is the type of modulation of the carrier signal. So J will indicate that it's a single sideband suppressed carrier. And you're going to see SSB as the modulation and the type of mode that we use for most maritime and aeronautical communications will be on this SSB. The 3 as part of the J3E is indicates a single channel containing analog information. I think 1 and 2 are either a single channel containing digital information, and maybe 2 is a double channel containing digital. 3, the single channel containing analog. They don't really test us on the middle one. The E indicates telephony, which is going to be basically everything you can hear over a telephone. Traditionally, it's going to be music and voice, regular conversations. The following are the simplified designators that are commonly used in the GMDSS system. J3E is the most common. That's the single sideband, the spoken word communications. Apparently, if it starts with an F, it's going to be frequency modulation. If it starts with a G, it's phase modulation. The F and JB, that's basically getting into narrowband direct printing or digital selective calling. And if it ends, if it's F3E, that's a facsimile, which I think we're going to get to the point I'm going to have to explain what faxes are. But I think even your generation early on was exposed to the fax machine. So it's basically a printed page. You can find the complete list of emission designators in a book that you're carrying in a GMDSS vessel. But for test purposes, we're just going to look at a few of them and test your memory a little bit. So let's get into the first one. All right, to set up the MF-HF transceiver for a voice call to a coast station, the operator must. All right, so you're setting up the transmitter, the transceiver, the receiver transmitter, and you want to call a coast station by using your voice. How are you going to set that up? What mode are you going to select, presuming you have the right to select the mode? Whoops, stop sharing. All right, and your options are to select J3E mode for proper CITOR operations. B, select F1B mode or J2B mode, depending on the equipment manufacturer. C, select the J3E mode for proper voice operations. Or D, select F1B, J2B modes or J3E mode, depending on whether FCC or ARQ is preferred. All right, I'm going to explain some of those. Maybe not right now. Maybe in a second or two. But the main thing they're asking here is for a voice call. So how are you going to set this up for voice? And we did see that the J3E is a single sideband that is used for voice. So I see that pretty much narrows me down to A or C. Now I'm going to see that A is talking about CITOR operations and C is talking about voice operations. At this point, I might not exactly remember what CITOR stands for, but I do know what the word voice means. As a matter of fact, it's the same word that is in the question. As a matter of fact, I think that's the only time there is a word that matches the question. So all of a sudden, C goes way up in my book. Let's see. Yes, it goes way up right to the actual answer. So if you're setting up a transceiver to transmit by voice, you might want to look for the answer that has you setting up for voice. Mode J3E is single sideband suppressed carrier using upper sideband for voice operations. Go into a little bit of that here. Okay, J3E, like I said, they don't really test on the 3 part, analog or digital. The J, not really, but they do test, it seems, if you know the last character, like the E. And kind of think of it as technology increased. You started with A, oral telegraphy, which is the telegraph that's intended to be decoded by ear. So you actually had somebody on the other end. Samuel Morse is sending out his Morse code, and the receiver is listening to it and writing it on a piece of paper. That's basically where all this started. B, then they moved it into electronic telegraph, where it was to be decoded by a machine. So basically, the machine would type out words, and then an operator would actually take the little strip and put it on a message. I do have an old telegraph that was sent at my birth, so I've got the telegraph. I should probably bring it in. C, that's a facsimile machine, still images. D, data transmission. That's telemetry or telecommand. It's remote control. Your remote control switch for your television sends radio waves to your television. E, telephony, which is voice or music intended to be listened to by a human. And for the most purposes, that's what your experience with the radio has been to date. You turn on the radio and you listen to somebody's voice or you listen to some music. That's E. That's probably the most common. And if the question does ask for something like that, look for the E at the end of the code. F, video. All right, let's see what we have here. To set up MFHF transceiver for a telex call to a coast station. So before it was a voice call to a coast station. So now what mode are you going to select? End pole. Did I share that? Kind of old news now. All right, so basically you're going to be looking at one of these emissions, and how are you going to set it up? This time it's not for voice, it is for telex. We're not exactly sure what telex is, but let's see if we can discern an answer from this. Is it A, select J3E mode for proper site-tour operations? Again, that's a single sideband telephony, which is a voice. So telex doesn't sound like it's going to be voice. So this time I'm not going to pick that. And I see that C isn't repeating what it was before. So we're not really going to have that. B, select F1B mode or J2B mode, depending on the equipment manufacturer. Now, if you remember, A was telegraphed by voice. B was telegraphed by machine. Now, that might be it, telex. And that was the mode, the B mode. As a matter of fact, that first list did have F1 and F1B and J2B. So that one, I'm not going to discount that one. How about C? Select F1B, J2B modes, which so far that's kind of part of B, or J3E mode, which is kind of part of A, depending on whether ARQ or FEC is preferred. Now, are those just words thrown out there to distract us? It might work. It may, people may be distracted by that, or none of the above. So far, I've seen that none of the above doesn't really apply to any of these answers. All right, so we're going to set up our transceiver for a telex call. I like B the best because it is the telegraph electronic mode, the B, and it's also the one with the two different options depending on the type of the equipment manufacturer. So I'm taking B, yes. I think that was a little further back. Yeah, there it is. F1B or J2B, narrow band direct printing or digital selective calling. And when we looked at the B, that was the electronic telegraph, which I guess would work for telex. All right, so just to explain some of the terms that we've seen so far, but SSB is single sideband modulation. Now, you might be familiar with the traditional types of modulation, AM and FM, amplitude modulation, and frequency modulation, which you're going to, if you haven't already been exposed to that, you certainly will be. But single sideband modulation, let's call that a third type. It could also be called single sideband suppressed carrier, which we did see in one of the explanations, SC. It's a type of modulation that is used to transmit information such as an audio signal, like voice, by radio waves. A refinement of amplitude modulation, it uses transmitter power and bandwidth more efficiently. Yes, instead of transmitting on the whole band, basically it takes the center band, which is the carrier wave, and it only operates on one side or the other. And in this case, I believe it's upper sideband as opposed to the lower sideband. I think you get exposed to that a little bit in chapter 4. Data transmission error correction mode. So that's voice transmissions. If it's a data transmission, there's two different methods of correcting errors: FEC and ARQ. FEC is a method of obtaining error correction in data transmissions in which the transmitter sends redundant data and the destination receiver recognizes only the portion of the data that contains no apparent errors. So that's called forward error correction. ARQ, it's a method that's used as a fallback to correct errors that are uncorrectable using only the redundancy sent in the initial transmission, like FEC uses. There's redundancy, so if some of it's bad, they get rid of the bad part and just keep the good stuff. But if that fails, sometimes there's a fallback in ARQ where the receiver sends an alert to the sender if something is missing so that the sender can resend the missing packet. And that's all automatic. And as a matter of fact, ARQ, the A stands for automatic. So the next question does toss some of these together with some other ones. So here's the question. Which modes could be selected to receive vessel traffic lists from high sea shore stations? Now, we saw vessel lists before. We saw that the coast station doesn't necessarily call you up personally. They are going to transmit these lists at a certain time every few hours. And it's going to be a list of those ships or call signs that they have traffic for, that they have messages for. Now, what mode would you select on your transceiver in order to receive those lists? The options are AM and FM. You can see these questions are getting a little tougher. Get through this medium high frequency stuff and you coast down the backside of it. So for element 1, these might be some of the tougher questions, and some people just rely on memorization. Once you work with the material a little bit more, you might be able to use a little bit of a logic in order to move one or the other out of the way. But the options are A, AM, and in effect FM. B, ARQ and FEC. Well, so far AM and FM are the older modulation methods. ARQ and FEC, those are the two data correction, error correction methods. C, VHF, FM, and single sideband. Well, so far we're getting pretty good because we do like single sideband, and that is generally the modulation mode that we select for most maritime communications. Can we also listen to it on your FM radio dial? Probably not. And SSB and FEC. Well, SSB is in there, single sideband. So that would be for the voice. So you're going to actually listen to the traffic list. And FEC is going to be, since it's a data transmission correction device, that might be something that you use for any type of data transmission. Maybe they're sending out this list in some sort of radio telegraphy where you can actually look at a list that they provided instead of sitting there and listening through the entire list. I would probably prefer just to see the list, quickly scroll down to see whether or not I personally have any traffic or anybody else that I might be in immediate communication with. So doing that, we did narrow it down to single sideband and forward error correction for the data portion. All right, whoever answered it did pretty well. You might already be studying for this because we're down to the last just handful of questions. All right, do we have anything else? No, that's it. All right, I appreciate that.